Hey, this is Math 2, Unit 8. This is your review worksheet, and it does say right here, no calculators allowed. You're working on radicals, and that's part of the lesson here for this unit, and they want you to be able to do this without calculators. So just know I'm going to go through a lot of these problems. There will be a few that I skip just so that I don't give you every answer, but you'll get the hang of most of it. So here we go. First of all, we have this expression right here. We want to simplify that. So it's like combining like terms. So I have a 7 plus 8, and 7 and 8 together combine to make 15. Here they have the same root 3, so I can combine them almost like a variable, like an a. There's like 2a minus 1a. That's how you can think of that there. So 2 minus 1 is simply going to be 1. So I can either write a 1 if I want to, but the radical stays simply the radical like that. So I don't actually need to put the 1 there, but I just wrote it to start with, so you can see that's 2 minus 1. So really it just becomes 15 root 3 as your final answer there. For number 2, same idea. Now this is subtraction, so be careful. This becomes like minus 2, and minus becomes plus 4 root 13. So now when I combine like terms, I have 3 and a minus 2. 3 minus 2 is 1. And here I have 2 plus 4. 2 plus 4 is 6, and the radical still stays root 13, just like that. And that is it. Yep, that's all there is to that one. Interesting. I put something different before. Let me double check. I put down 2. Was going too quick. Yep, because so minus and minus becomes a positive. So yep. So that's it there. Number 3. This becomes a minus and minus becomes plus 4, and this becomes a plus 2, right? So now combining 10 plus 4 is 14, and 5 plus 2, sorry, is 7. So we're going to say plus 7, and we still have a root 7 there. Over here, minus and minus becomes a plus 3, minus becomes a plus 7. Kind of combining like terms, 5 plus 3 is 8. And then we have 7 plus 2 is 9, and we still have a root 5 there. That's how we do this first part. Okay, down below, complete the table, simplify each expression, and check the appropriate box for rational or irrational. So basically, irrational means we still have some kind of radical thing going on in it, so that becomes a irrational. Okay, so here we have a minus 2 root 3 and a minus 2. So this stays a minus, this becomes a plus, right? So this becomes a minus there, and that becomes a plus. So 2 root 3 minus 2 root 3, that means they go away, cancel each other out. And 5 plus 2 is simply 7. So simplified expression is going to be 7, and that's a rational number there. Here we have the same bases, or same radical, 5. 17 plus 3 is 20, and a root 5 there. So we can rewrite that, and simplify as 20 root 5, and that has a radical, so we'd say it's irrational. For square root of 100, that's the same as 10 and 10, so 10 goes on the outside, plus 4. 10 plus 4 is 14, and that is rational. 16 is 4 times 4, so because there's a partner there, that goes on the outside now. 4 times 14, and 4 times 14 is 56, whole number, it's rational. And square root of 7 times square root of 4, well, square root of 4 is 2 and 2, so that goes on the outside as a 2. So we end up with square root of 7 times 2, or 2 root 7, which is irrational. Alright, number 6. Again, this is part of the test here, and probably kind of the weirder part, I think, just the way it's phrased, so just be careful. It says provide a counter example for the following statement, which means prove that it's wrong, okay? So it says the sum of 2 irrational roots numbers is always irrational. So what we want to do is we want to find the sum of 2 irrationals that is always irrational. We want to find the opposite. So we want to find the sum of 2 irrational that is going to be rational. Okay. So we want to make the sum, doing the counter, the sum of 2 irrational. We want to make it the opposite. We want to make it rational. So here we go. If I did the square root of 3 plus negative root 3, right? Are those 2 irrational square roots? Yes. Am I doing the sum? Yes. And root 3 minus root 3 equals 0, and 0 is a rational number. So that is a counterexample, showing that that's not true. It's not always irrational. It can be both. All right. So just be careful with the wording of these ones. All right. That's all I can really say about it. The product of two irrational square root numbers is always irrational. So we want to find the product of two irrational and make it. We're going to try to prove that it's irrational. So let's do this product of two irrational. So it's root 2 times a root 2. Well, we want to try to get that. Root 2 times root 2 is the same as root 2 times 2. Because there's a partner, they go on the outside. That's 2, and 2 is a rational number. So I'm just proving that it's not always irrational. It can be rational, right? We just proved it so. The sum, so adding two irrational cube roots, is always irrational. Again, this is just like A, right? I can do a cube root of 2, and I can add that to a negative cube root of 2, right? Same idea, because this plus that are going to cancel each other out to get 0, and that is going to be rational. So you're just taking the same one, making one negative to make it equal to 0 total. Okay, the product of two irrational cube roots is always irrational. No, not always, because what if I had the cube root of 3 times the cube root of 9? I think, well, I don't know, does that work? Well, that becomes rewritten as the cube root of 3 times 9, and 9 is 3 and 3, and here I have a triplet, 3, 3, 3, cube root of that equals 3, and that's going to be rational. So to prove that, I took a number that I knew if I was to break it apart, it would match that one. When I combine them together, I get 3, and that's what I did there. So there's an example for how that works there. Kind of weird, but there it is. Okay, number 7. This is from like your homework the other day. So same idea. You have to use these numbers and choose two numbers that when you multiply them, it's rational, and when you add the same two numbers, it's irrational. So let's take, for example, if I did root 5, square root of 5 times 3 root 5. Okay, when I multiply those, what do I end up with? I have 3 root 5 times 5, which is going to be 5. So I have 3 times 5, which is 15. That's rational, good to go there. But when I add them, root 5 plus 3 root 5 is simply 4 root 5. That's irrational. So that works there as an example, right? Using 5 and 3 root 5. You could use other ones, that's just one example. So when I multiply them now, next one I want irrational, and when I add them, it's irrational. Okay, so multiply and I get irrational. So 5 times, let's do 5, and we can do the root 5 again, or I can do root 3. Let's do root 3. 5 times root 3 equals 5 root 3. That's irrational. So what is 5 plus root 3? It's just 5 plus root 3, so it's irrational. So that's an example there. So 5 and root 3. So again, you can use other ones, up to you. That's just an example there. Okay, here we go. Reviewing stuff from other lessons too. Simplify, write the final answer using only positives. So here we go. So we're going to take this cube. This cube has to move all the way through all the pieces of the puzzle. So 2 cubed is 2, times 2 is 4, times 2 is 8, so that becomes an 8. For the exponents, we multiply. 2 times 3 is 6. And for the y, 7 times 3 is 21. And that's what we do there. For number 9, we're going to multiply that exponent all the way through. So negative 4 squared. Negative 4 times negative 4 is 16. On the x side, 4 times 2 is 8. And on the y side, 2 times 2 is 4. For number 10, we have a negative 2 up here, so we have to move that all the way through the whole thing. Okay, so let's just go ahead and do that first. So this becomes 3 to the negative 2 power. X to the 4 times negative 2 is negative 8 power. All over y, negative 2 times negative 2 is negative 4 power. Okay, so with that in mind, let's then move things around. We don't want to have negatives, so we got to move things up and downstairs. So 3 squared is 9. We're going to move that to the bottom because 3 to negative 2, we move it down there. X to the 8th negative 8 moves downstairs, x to the 8th, and y to the negative 4 moves upstairs to the y to the 4th. And we leave it like that. Number 11. Okay, first thing I want to do, I'm going to move that negative 4 through all of this and rewrite. So I have 3x negative 3 k to the 4th times x 2 times negative 4 is negative 8, and for the k, 3 times negative 4 is negative 12. Now I'll multiply things together. The 3 just simply stays a 3, no problem. Here I have x, and I have negative 3 plus a negative 8 is a negative 11. And for the k value, 4 minus 12 is minus 8. I don't want to have negative exponents. I'm going to rewrite this then as 3 over x to the 11th, k to the 8th, and I'm all good there. For number 12, I'm going to go ahead and move that cubed all the way through. So I have m squared k to the minus 3, right? And that's going to be times m to the 2 times 3 is 6, and then k, negative 4 times 3 is negative 12. Now we'll combine things together. For the m, I have 2 plus 6. 2 plus 6 is 8. And for the k, negative 3 plus a negative 12 is a negative 15. And we're going to rewrite that as m to the 8th over k to the 15th. Something like that. Yeah. Double checking my work there. I got a little sloppy in my notes. That's something different. Double check. That's 12. And 12 plus 3. Yep, 15. Okay, and number 13. And I move this negative 2 all the way through first of all. So first I have I have x to the negative 4th y times, and then I have 3 times negative 2 is negative 6. Y, 2 times negative 2 is negative 4. Now we're going to add things up. Negative 4 plus a negative 6 is a negative 10. And for the y, this is a 1 minus 4, which is minus 3. So that becomes 1 over x to the 10th, y to the 3rd. And that's it for that one. Okay, 14, 15, 16 are the same kind of thing, so I'm not going to do those ones. It's going to be good practice for you. All right, 17. Here we have x to the 5th, y4 over x3, y1. Right? So I can just do subtraction. 5 minus 3 is 2. So I have x to the 2, x squared. And then 4 minus 1 is 3. So I have y to the 3rd. Nothing on the denominator. That's just where I stop. For number 19, I get the same kind of thing. I have minus 7 minus a minus 2 becomes x to the minus 5. And for the r, I have 4 minus a minus 3. 4 minus a minus 3 is 4 plus 3, which is 7. I don't want to leave it like that because I can't have a negative exponent, so I rewrite this as r to the 7th over x to the 5th. Okay, number 21. All right, so we have some x and y values. So 21 over 7. 21 over 7 can be reduced to 3. For the x, we have 7 minus a negative 5, which equals 12. So x has a positive 12 value. For the y, we have 2 minus 8, which is a minus 6. So that tells me y needs to be downstairs. For z, we have a minus 4 minus a minus 9. So that becomes a 9 minus 4, which is a positive 5. So z needs to be upstairs. So we have 3, x to the 12th, z to the 5th, y over 6 as our final answer there. Okay, number 23. We have this cube on the outside, which means it needs to go through everything. So 3 cubed is 3 times 3 is 9, times 3 is 27. Now for this one, we have x to the 2/3 times 3, or 3 over 1, right? I multiply that out. That becomes reduce, x squared is all that's left. So all we have left is 27x squared. 25, same kind of idea. We're going to put the square all the way through. So 4 squared is 4 times 4 is 16. And x becomes 1/5 times 2, which is 2/5, and we just leave it like that. All right, and that's it for 25. Let's look on the next page, number 20, page 26, number 26. Okay, 64. So 64, and we have this to the 4/3. So we're going to do this to the cubed and then 4th. So we're going to take the 64 and break that apart, and that can become 4 and 16, which becomes 4 and 4. All right, so 4 times 4 is 16, times 4 is 64, and we have a triplet, which means all those move outside. So we have 4, don't forget the exponent there, moving it over. So 4 to the 4th power, and 4 to the 4th power is 256, and that's our answer for that guy right there. For 27, same idea. This is 25 when we have squared, so square root of 25 and the whole thing cubed. All right, so what's the square root of 25? Well, it's 5 and 5, so we have 5 on the outside now, and we're going to cube that, moving it over. So 5 times 5 is 25, times 5 is 125, and there we are. And the last one here, we're going to cube root it. So there's 125 cubed into the first power. That becomes 5 times 25, which is 5 and 5. There's our triplet, so on the outside is simply 5. Number 29, x to the 3/5. We're going to rewrite this here as x to the 3/5 times, and this is x to the 2/10. Because I have the same base, I can then add these together, but I need to make sure my fractions have the same base as well, or same denominator. So I want to make the same denominator. I can reduce 2/10 to 1/5, can't I? So I'm going to make that into 1/5. Now I can add. 3 plus 1 is 4. And 5th stays on the bottom. So I have 4/5 right there. Interesting. I have a different answer in my thing here. Let me think why. Just looking real quick. I have a negative. Oh, sorry. That's why. Sorry. I forgot one thing. This is a negative. There we go. Correction. That's a negative. So negative 1/5. So it's 3 minus 1, which is 2/5. There we go. Don't forget that. Adds in the denominator, so it has to stay negative. So it's 3 minus 1. Okay, that's why you check your work. All right, so we have x to the 2/5 power. No problem. Let's look at 31. Same idea, x to the 4/5. And then we're going to do x times, this is 4/10, but it's a negative, I won't forget this time, 4/10. We want a common denominator. Let's go with the 5. So I can reduce this down to negative 2/5, right? So 4 minus 2 is still 2, and the denominator is still 5, and I have x to 2/5. Same answer I got before. Different problem, same answer. All right, that's 31. Number 32, write in exponential form. All right, so this is x to the 3/4 times, and that's a 5th root, so it's times 1/5. When I have exponents, I multiply together. 3 times 1 is 3, and 4 times 5 is 20, so I have x to the 3/20th power. For 34, same idea. Here we have x to the 6/8 to start with, and that whole thing is multiplied by a 4th root, right? 1/4. So I can reduce first if I wanted to. Right? That's okay to do, or I don't have to. It's up to you, whatever you want to do. I'm going to reduce. That becomes a 3. That becomes a 2. So I end up with x to the 3/16. If I wanted to not reduce, I could have this as x to the 6/32, but then I can just cut that in half and still end up with x to the 3/16. Up to you what you want to do first. Number 35. Simplify and write in exponential form. So this becomes 2 to the 2/9 times 2 to the 2/3. 2/3. Before I add those, I need to have a common denominator. I can't reduce, so let's make this bigger. This becomes, if I want to make that a 9, I multiply top and bottom by 3's. So it becomes 6/9, right? Now I can add 2 plus 6 is 8. And the denominator stays a 9. So 2 and 8/9. And number 37, here is 6 and 4/5 times 6, and this becomes 3 squared. Why squared? It's just a regular old square root. You don't have to write the 2 if it's a regular old square root. If I want to add that up, I need a common denominator. So it's basically saying I have 4/5 plus 3/2. To make a common denominator, I'm going to go with 10s and 10s. To make that a 10, it's times 2. So 4 times 2 is 8. This is times 5 times 5. 3 times 5 is 15. So 8 plus 15 equals 23 over 10. And that becomes my exponent with my number 6 down here. So 6 to the 2/3 10th power. Okay, complete the table, write in simplified exponential and radical form. All right, so this is 27x to the 2/3 power. I can rewrite this as 27 to the 2/3 and x to the 2/3. Okay, this becomes the cubed root of 27 squared. The cube root of 27 is 3, and 3 squared is 9. That stays what it is. So I have 9x to the 2/3, right? That's exponent form. To write that as a radical, the 9 still stays on the outside, and this becomes a cubed root of x squared. So I'm rewriting that part to there. For this next one here, again, I have the 3 over 2. That goes to each part, so it's 16 3 over 2 times x to the 5th times 3 over 2. Okay, so this becomes a square root of 16 cubed. Square root of 16 is 4, and 4 cubed is 64. All right, so that's that part. And here this becomes x, and 5 times 3 is 15 over 2. So an exponential, I do 64x to the 15 over 2. Kind of weird, I don't know. And then put that in radical form. That one's a little different, okay? Because this part here can be changed a little bit. It can? Sure it can. Because this is x to the 15th power. That's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? That's a square root of all of that. But here's a pair. That's 1, 2, 3, 4, 5, 6, 7. Right? So I actually have 64 x to the 7th power, and what's left on the inside is x, 1x. I don't really want to put this as square root of x to the 15th. I could. It really is a square root of x to the 15th, but the x to the 15th can be reduced down, simplified to x to the 7th times x to just x. Okay? Number 41. Simplify and express in radical form. So we have to add those up. 1/6 plus 1/4. 1/6 plus a 1/4. Need a common denominator. I'm going to go with a 12. 12. This becomes 2 over 2 to get to 12 this way. And over here it's times a 3 times a 3. Add them up. 2 plus 3 is 5. Denominator is still 12. And my whole base stays an 8. But I want to write it in radical form. So that becomes 8. And this is the 12th root. And all that's to the 5th power. A little weird, but that's what it is. Over here we have 1/5 plus 1/3, right? Need a common denominator. We're going to go with 15. 15. So this is times 5. 5 over 5. Let's get 15 there. This is times 3 over 3. Add them up. 3 plus 5 is 8. So I have 8/15ths, and this is 2, so 8/15ths. So all I did here was just add. Can you add 1/5 and 1/3? And that gets you 8/15ths. And now I have to rewrite this. This is 2 to the 8th power, and this is to the 15th root. Kind of weird, but again, that's just what it is. Okay, flip it over to the last page for your review. Write in exponential form and then solve for x. All right, so square root of 16, I can do this first. Square root of 16 is 4, and that's 4 to the 3rd. And the square root of 16 is 4, right? And that's 4 to the 10th power. Now, real quick, before I do all that, let me back it up. Back it up. Forgot what I was doing here. This one wants you to solve for x. So we're trying to get it in that form real quick. So I'm going to back up real quick. And what I really want to do is this. Rewrite it. This becomes 16 to 3 over 2 times 16 10 over 2. I'm just rewriting it real quick because I want that to equal 16 something over 2. My goal is to get it in that same shape. So now because of the same basis, this is 16, and 3 plus 10 is 13 over 2 equals 16x over 2. So all I'm trying to do is get to the value of x. I was just trying to do I was doing extra work there at the beginning. So what is x? X is equal to 13. Okay, so don't work too hard there. So here I want to get this. I want to get this side into that shape. So this becomes rewritten as 64 7/3 times 64 7/3. Same base, same denominator. I can add that up. That's 64 to the 14/3 equals 64x over 3, right? Let's bring that down. So what does x equal? X equals 14. That's all they're asking you to do. Same for 46. Here I want to get it in this shape. So I have 8 3/2 times, and here this is 8, be careful, negative 4 over 6. I want to get into a 6 denominator, so I'm going to change that to 6. So change it to 6 becomes multiplying top and bottom by 3. So that becomes 8 and 9 6 times 8 and a negative 4 6, right? So I did a denominator change here to turn that into a 6. 2 times 3 is 6. I did the same at the top. 3 times 3 is 9. So I have the 9 over 6. 9 minus 4 is 5, 6. And so I set that equal to my other one. So 8 and 5 6 equals 8 and x over 6. So what does x equal? X equals 5. And the last one here, we have 3 and 1/4 times, or to the 1/6 power, because it's a 6 there. We want that equal to 3 over 1 over x. Okay, so now it's on the denominator. So I multiply this out, and I have 3 to the 1/24 equals 3 or 1 over x. So what does x equal? In this case here, x equals 24. All right, I skipped a couple there so you can practice on your own. And over here, write an equivalent expression to the following in the form of a to the m times a to the n, and that one there. So here we have a to the 14th, and there's lots of answers here that could work. I could make my m value here 7, and my n value 7, because when I add those together, I still get a to the 14th. And then over here, I could say a to the 7th, and then I could square it, and I still have that equal to that. Okay, they don't have to be the same numbers, just whatever works for you. However, I can get the 14. So here, how do I get the negative 12? I can say a to the negative 8 times a to the negative 4. That gives me negative 12. And in this format, I could say a to the negative 6 squared, because that gets me again negative 12. And finally here, I could do p to the 15th times p to the 5th, because 5 plus 5 is 15. Or I could do p to the 4th and all that to the 5th power, because 5 times 4 gets you 20. That's really it. It's just a lot of practice, a lot of repetition there with this unit. Good luck on your test, and we'll see you for the next unit.